Hello, this is part 6 of Lab A, configuring an ASA 5505 device using the command line interface. In this part, what we're going to do is we're going to set up the demilitarized zone, or DMZ, on VLAN 3 for our ASA device. If we look at the diagram, you can see that the ASA device has VLAN 2, which is the outside interface, VLAN 1, which is the inside interface and the inside network, where we have our 192.168.1 network. And then we're going to connect also on Ethernet port 2 on the ASA device to S1 over to PCA for our VLAN 3 DMZ. Now in the DMZ, we're going to run a web server located at PCA at 192.168.2.3. So to do this, we're going to need to configure the ASA device with a third VLAN. So let's do that now. All right, I've got a console connection to the ASA device, as you can see here. And all I have to do is say int for interface VLAN 3, and it puts me into interface configuration mode. And now I can start configuring interface VLAN 3. IP address 192.168.2.1. We're going to give it a /24 subnet mask. All right, done. Now this IP address for this VLAN, this is going to be the 2 network. You can see 192.168.2.0, and for this server, the ASA is going to be the gateway at .1 or 2.1. So we've set the IP address. Now what we need to do is set the named interface. So we'll say name if DMZ. And as soon as I do this command, we're going to get an error, and I'll talk about it in a second. So there it is, name interface DMZ. We get an error that reminds us that with the base license that we're operating on the ASA 5505 device, only 2 interfaces can have names, and the third interface, if it wants to have a name, can only communicate with one of the other 2 VLANs. So we need to use the no forward command on at least one of the VLANs. In other words, we can have an outside VLAN and an inside VLAN, but if we want a third VLAN, VLAN 3, then it needs to only communicate with the outside and not directly across to VLAN 1. And we can do that by saying no forward interface VLAN 1. Now let's try to put that name IF in again for DMZ, and you can see it takes. Now we get a message back that the security level for the DMZ has been set to 0 by default. Now 0, the security level of 0 is the most untrusted or the untrusted setting. A trusted network has a security level of 100. That's the highest amount of trust. And the least amount of trust is a 0. So what we're going to do is we're going to set the security level for our DMZ to 70. All right, and then we'll do a no shut command to activate the interface, and now the interface is up. Now, just to remind you about security levels, when you're having data travel from a high security level, let's say like a 100, to a lower numbered security level interface, that data can go across by default. So data moving from the inside VLAN can go across the ASA device through VLAN 2 because that has a lower security level. Also, data will now be able to travel from VLAN 3, where our server is, also across to VLAN 2 because it'll be going from security level 70 to security level 0. But you cannot, by default, have data travel from a lower security level number to a higher level. So by default, traffic is blocked going from VLAN 2, which is security level 0, to VLAN 1, security level 100, or VLAN 3, security level 70. Now, the question you want to ask yourself is, what about data traveling from VLAN 3 with a security level of 70 to VLAN 1? Well, we've already disabled that with the no forward command, but even without the no forward command, by default, if it's going to go from a security level of 70 to 100, that's going to be blocked by default. Okay. So now that we have that interface set up, we can look at it, show, run, In our running configuration, you can see that interface VLAN 3 is set up. It's got the IP address 2.1, security level 70, and the name, and it's been activated. So now what we need to do is apply that switched virtual interface, that VLAN interface, to Ethernet switch port 2 on the ASA device. If you remember, I unplugged the Ethernet cable from port 2 on the ASA device, and I'm going to talk about that in a second. But first, let's set up port 2 with access to VLAN 3. So what we'll do is, we'll say Q to exit out of there. There we go. And we'll say interface Ethernet 0/2. That takes us into port 2. And now we can do an SW tab, switch port access VLAN 3. No shut. So now the switch port has been configured for VLAN 3. And what we can do now is we can connect that Ethernet cable to the switch port. So I'm going to take this and set it up. All right. So now we're connected from the ASA device to switch 1, which is connected to PCA, which is running a web server. All right, more configurations. We do a show run. You can see now that interface Ethernet 02 switch port access VLAN is up. And let's run a quick show command. Let's do a show interface IP brief. And you can see from this command that port 2 is indeed physically up and the protocol is up. If I was to unplug that Ethernet cable and issue the same command again, you can see that it now shows up as down and down. So plug that back in. If we do a show IP address, we can see our interfaces here with the VLAN and then the name of the VLAN here, the inside, the outside, the DMZ, our IP address, and our subnet mask for the different interfaces and VLANs. And we can do a show switch VLAN, and this command would be like a show VLAN command on a 2960 switch, in that it shows us our VLANs, the name of our VLANs, the status, you can see that they're up, and also which switch ports on the ASA device belong to which VLAN. Okay, moving on. When we set up VLAN 2 and VLAN 1, we set up network address translation, or NAT, to translate our private addresses on the one network to our public address at 209.165.200.226. So what we need to do now is set up a form of network address translation to translate our server at 192.168.2.3 to a public outside IP address. But instead of using 226, which our network is already using, let's pretend that our ISP has granted us another public IP address at 227, and we want to set up a static translation to translate our server's address 192.168.2.3 to a public IP address that we're going to use on the outside. So what we'll do is we'll set that up now. I'm going to do a conf T to get to global config mode. And then I'm going to access the object network, or the network object, and set up a network object for DMZ-server. And I'm following along in the lab, and this is step 2 in part 6. So we do that, and now we're in configuration network object mode. And we're going to set up, first of all, what addresses we're going to be translated. And the address that we're going to translate is just one host. So we're going to say host 192.168.2.3, and then our NAT command. So NAT from the DMZ to the outside interface in parentheses and a comma between DMZ and outside. And then this is, instead of a dynamic translation, this is going to be a static translation, and then we can put the IP address that we want to translate it to. So in this case, 209.165.200.227. All right, and that's it for setting up our NAT. Now that network address translation has been set up, the IP address, when traffic flows from the server across the network, it'll be translated from 2.3 to the public IP address at 227, 209.165.200.227. But there's one other problem, and that is the problem of the firewall. If a user, let's say at PCC, wants to access our website, let's go there now. I'm going to open up a remote desktop connection. I've got a remote desktop connection right now to PCC located at 172.16.3.3. And if I put in the IP address of our server, 209, let's see here if we can get this in. 209.165.200.227, you'll see that nothing comes up, right? And if I was to open up, let's say, a command prompt and try to ping that host, there's a command prompt, and we try to ping it, we're not going to be able to receive a ping as well. So you can see here that the pings are timing out. Well, why is that? The reason for that is that, once again, the security level of the outside interface is a 0, and the security level of VLAN 3 is a 70, so traffic from the outside is being blocked as it tries to cross the ASA firewall. So to fix that problem and allow traffic to go through and go to our web server, what we can do is set up an access list. So let's do that now. So what I'm going to do is I'm going to go to global config mode again. I'm going to say access-list, and then it's going to be a named access list, so let's give it a name, outside-DMZ, permit IP traffic from any source IP address to host 192.168.2.3. And that's our access list. And now we need to apply it to an interface. What's nice about this is we don't have to actually go into interface configuration mode to do it. We can just type access-group outside-DMZ, matching the name of our named access list. And we'll say inbound on interface outside. So when we put this command in, our access list is applied on the outside interface with inbound traffic. And when it reaches that, it'll permit IP from any source address if they're trying to reach host 2.3. Now what's interesting about that is that when they contact our server, they're not going to be contacting the private address at 2.3. They're going to be contacting the public address at 209.165.200.227. But the ASA firewall will translate this automatically, so all we have to do is put in the private address here in the access list, and the firewall will do the rest. So now that we've done that, let's test it out. Now to test this out, in the lab, they want you to do something different. They want you to telnet over to R2. So I'm going to do that now. Got a command prompt here. Put in Cisco, enable, Cisco, and now I'm in R2 in privileged user mode. So now that I'm in R2, they want you to set up a loopback interface. So we'll say interface, well, first we have to go to global config mode. Interface LO for loopback, 0, and then set it up with an IP address. And they just use a dummy IP address that's not any network that's been used in the lab so far. So 172.30.1.1, and then they give it the subnet mask, and that's done. And now if we do a Control C and we run a ping, and let's try to ping 209.165.200.227, which is going to translate over to our web server, and we're going to say source. This ping will go from source LO0. And you can see the ping is sent from that loopback interface, and we get success. Let's go over to our PCC in the diagram. Let's see here. This PC right here, the one that I have a remote desktop connection to. And let's see if we can get that web page up. So we'll go over here, and we'll hit refresh. And it should work now. Hey, there it is. What's up? So the web server is working, and we're able to receive our home page on our web server at PCA. And I believe that's all of the steps that are covered in step 6. Let's, before we go, look at our NAT translations. So before we do, we'll add one other piece. We'll go back to our console and we'll say show XLATE, or show translate. And you can see, if we look at our translation, you can see some of the translations. There's 3 currently in use. And you can see we're natting from DMZ 2.3 to the outside at 227. All right, and you can see that we're also padding from the inside, port address translation 1.6 to the outside interface at 226. And if we look at some of these flags, you can see that for the NAT translation from the DMZ, the flag is S for a static mapping. And for the PAT translation from the one network to the outside interface, the flags say R and I, which are a port map. In other words, it's a port address translation, and the I shows us that it's a dynamic translation. So that's just a little of the show translate command. We can also do a show NAT command and look at our network address policies, our network address translation policies, and you can see that we have 2 now. We have the DMZ to the outside, and we have the inside to the outside. All right. Okay, that was part 6 of Lab A, and that ends Lab A for the CCNA Security Curriculum Chapter 10, Configuring the ASA 5505 device using the command line interface.